I'm here today to speak about the next generation of 3D printing that allows us actually to 3D print silicon structures. So to start with, let me back up a bit and motivate why we want to 3D print silicon structures. Well, silicon is one of the best understood engineering materials in the world. It exhibits really excellent mechanical, electrical, and optical properties. And because of its excellent mechanical properties, you will find it in pretty much every sensor, for example, in your mobile phone. These sensors consist of very small and fragile silicon structures that have these complex 3D shapes, as you can see here in this image. And with having these silicon-based sensors in pretty much every consumer device, you can imagine how much research and development is ongoing in this field and how big the market actually is. So, but what does it actually take to manufacture a silicon-based sensor, for example? And the answer is pretty easy. It doesn't really matter if you want to produce one device or 1 million devices. You have always to go back to a traditional semiconductor facility, a processing facility. And this comes at an extremely high cost. And moreover, more complex shapes of 3D structures cannot even be realized by these kind of services. We therefore think that many really promising device concepts are not realized today because of this problem, and innovation hits a major roadblock here actually. So what we have come up with is a 3D printing process for silicon that is very similar to conventional 3D printing, as you all know it from, it's in the press everywhere. And it works like that you deposit a layer of material and you modify it by a laser source, for example. And this process is iterated over and over until finally a 3D structure comes to life. And what we do now is to bring this technology, this idea, this very concept to an entire new level by not only increasing the resolution of the printing process by several orders of magnitude, but also we use silicon, the best material for sensors, for this for the first time. So far, we have shown a very promising proof of concept where we have shown structures with several layers. And the beauty of this concept is that we don't reinvent the wheel, but we come back to standard processes. We just combine them in a novel way. And now it's up to the challenge to combine these two technologies and marry them and bring them together in a common standalone tool that we can actually take out of the semiconductor processing facilities that are very expensive. Thank you.
Software and digital data are now essential to the functioning of cities, deeply and pervasively embedded into the systems and infrastructure of the built environment, and in the management and governance of urban societies. Information and communication technologies and various software systems augment and facilitate how we understand and plan cities, how we manage urban services and utilities, and govern city life.
So the objective of the programme, or City Project, is to undertake a 5-year programme of research on how software, ubiquitous computing and big and open data makes a difference to how social, spatial and economic life takes place, trying to provide a groundbreaking interdisciplinary analysis of 2 core interrelated aspects of the emerging smart city.
First, translation and how cities are translated into code and data, and second, transduction and how code and data reshape city life. These processes of translation and transduction are being examined through 8 sub-projects organised with respect to 4 key urban practices: understanding, managing, working and living in the city. Each subject focuses on answering a particular key question and is staffed by one of 4 doctoral students or 4 postdoctoral researchers. An additional postdoctoral researcher is working on a sub-project that seeks to build smart city technology.